Hi, hello, and welcome back to our series on our EOS data center. I'm Karl, I'm from Wooden Data Center, and today I would like to talk with you about cogeneration, or also CHP, combined heat and power production. As you can see, we designed our data center with a series of large-scale engines or gensets. These are 10 megawatt gensets each, 11 of them, so an N+1 redundancy. So why didn't we go like with a traditional diesel route? To explain what cogeneration or CHP is, let me switch real quick. So here you see the schematics of an engine, or already two engines. Putting in the input is fuel gas and the output is power to the grid and heat to a heat consumer. So the traditional way it goes, like with any engine, you need fuel. The fuel is fed directly into the engine is turning, creating heat and rotation. The rotation is transferred to generator. The generator is producing energy. So since usually a diesel-backed generator is only purpose is to be creating redundancy at the grid, they have very low utilizations, or diesel is only there in case the grid fails for the data center. They have very low utilization, and they usually rev up around 300 hours of runtime in a 20 years period. So very, very low utilization, and it's very expensive. Newer technologies in Gas-Genset make it possible to have gensets that are gas-based and still revving up very quickly. Within 7.5 seconds they can deliver full capacity to the grid. So this can be used and operated not by the data center owner or operator, rather than by the utility, who's familiar with gas power plants anyway. And with a sizable data center like this one, where you have a 110 megawatt facility, which is a fairly substantial power plant, you then can go and produce 20 to 80% flexible load for the grid, with very high utilization if you manage. And that's the big if. Fully depends on location. You can go from 40 to 45% thermal efficiency from the fuel into the grid for the electric production, but if you add the heat usage on top of that, for heating a building, for feeding the energy into a heat grid, or for heating up greenhouses in wintertime, or other pharmaceutical processes or industrial processes that need energy, then you can go to a very high level of efficiency of up to 90%. And this is why cogeneration is so interesting, and it's just been enabled by recent developments in the ability to quick start just gas gensets, and making this not a huge capex for the data center operator, but maintenance, capex, fuel, running this for the grid is 100% paid by the utility. And only in the case of a grid failure, you have a power plant that you know works because it's not running 300 hours, but rather minimum 20% of the time to create flexible energy. And with that, you then have backup as a service and only pay for the hours that you actually have a failure. I believe this is a very easy thing to integrate into existing and new data centers, and would potentially lower the cost and the usage efficiency of backup solutions fairly substantially. This is so much for me today. Thank you and have a good day. Bye-bye.